Hello friends, welcome to my channel. Here I solve LeetCode problems and prepare to the code interview. Today's problem number is 1561, maximum number of coins you can get. There are 3 n piles of coins of varying size. You and your friends will take piles of coins as follow. In each size you will choose any 3 piles of coins, not necessarily consecutive. Of your choice, Alice will pick the pile with the maximum number of coins. You will pick the next pile with the maximum number of coins. Your friend Bob will pick the last pile. Repeat until there are no more pile of coins. Given an array of integers piles, where piles of I is the number of coins in the ith pile. Return the maximum number of coins that you can have. Mm, let's start. You can think that the best strategy for the solution is to pick the biggest 3 numbers of piles each in each step. So you can get first 3 piles and uh, alias will get the maximum number, so your number uh, is always second. So what we can do, we can sort initial piles list in descending order from maximum to minimum element, and after you can get every second item. So let's do it and check if we can solve it. So first of all we need to sort it, and we need to sort it in descending order. To do it we need to call method sort with argument reverse equals true. Now we have piles in reverse order, and we need to some result variable, and 0 by default. Let's return it. And now we need to add every second item to result. To do it, what we can do? So for, for I in range, we will start with from index 1, so it's the second number, until end of piles with step 3, because we will pick 3 items each step. So, and we need to add current pile to the result. Let's check the tests. You can see first 2 tests passed, but third not. There is a small problem in third test. You can see if we picked 3 largest items, Alice will get 9, you will get 8, and Bob will get 7. In this in second round, Alice will get 6 and you will get 5. But this strategy is not optimal because we can make it better if Bob will get smallest element instead of third largest. So if Bob will get smallest item, so it will be a 1 in first round. In second round, Alice will get 7 and you will get 6. It's better than we got previous step in previous solution. So the strategy will be uh, Alice will get always largest number and you, Elsa, will get second largest number, but Bob will get the smallest number in each step. So because Bob has the smallest numbers in each step, so he finally will get the 1/3 of the smallest items. So uh, we don't need to consider it. So we can check first to third of list and we'll get every second item started from second item. So let's change our loop. So it will be almost the same. Instead of we start from 1 but ends not at the end of piles but at the two third, and the step will be 2 instead of 3 because in this case we will check the largest numbers with Alice and don't consider Bob. And let's check tests now. All tests passed and it should be optimal. Let's submit it. It works and pretty efficient. Finally, let's analyze the time complexity. In the main loop, we go through initial list piles and it depends on the size of piles. So it has time complexity O of n. But before we sorted the piles and sort algorithm has time complexity O of n log n, and it's bigger than O of n. So we have to choose the biggest component of 2. So the to total time complexity is O of n log n. That's it for today. Thanks for watching. See you tomorrow. Bye.